Ladies and gentlemen, it's a great pleasure for me to introduce to you our keynote speaker. Johan Rockström is a Swedish professor. He is an international expert, specialist of water use and global sustainability. He currently heads the Potsdam Institute for Climate Research in Germany. We have asked him this morning to expose the consequences of climate change on social and economic issues. Professor Rockström, you are with us live from Germany. Good morning.
Yes, good morning. Wonderful to be with you.
Great. We hear you perfectly. We are very happy to have you online. Thank you for accepting our invitation. And before I let you begin your talk, I would just like to tell the public, our participants, that it is possible to leave comments and questions on our chat. We would like to offer you, our audience, the possibility to interact with Professor Rockström at the end of his speech. So please don't hesitate to use our Q&A during the presentation. It's on the right-hand side of your screen on the bottom line. So thank you very much. And please, Professor Rockström, now it's your moment.
Merci beaucoup, and I'm honored to be here with you at this important juncture. I'll be sharing my screen, and hopefully there we are. Hopefully this will work. So, ladies and gentlemen, what I will do is basically provide the scientific evidence that President Parmelin is absolutely right, that the banking sector must now speed up towards really transitioning where green finance becomes no more a corporate social responsibility, or at worst case, even a greenwashing, as President Parmelin pointed out, but actually being a strategic business, core business direction for the entire private banking sector. And of course, any such talk to provide the scientific evidence of transformative change in the financial sector must start with what I would argue being the most important scientific message to humanity over the last 20 years, namely that we have shifted from being this relatively small economy on a big planet to now being a very big economy impacting on the entire planet to the extent that we have become our own geological epoch. Can you imagine? We have now left the Holocene, the epoch we've been in since the last ice age, and are now in the Anthropocene. We are the dominating force of change on planet Earth. We are sitting in the driving seat, starting to hit the ceiling of hardwired biophysical processes that regulates the state of the planet. The scale, the speed, and interconnectivity is today unprecedented. We can even show evidence that the pandemic, which is not a black swan, a terrible global crisis, which was predicted, a manifestation of the hyperconnected global world in the Anthropocene. Now, the impacts of this are known and felt, and the drivers and evidence well established. I won't go through much of that actually, just to remind us that 2020 is the warmest year on record. The last 10 years is the warmest decade on record, but most importantly, we have now crashed through the warmest temperature on Earth since we left the last ice age 12,000 years ago. We are at 1.2 degrees Celsius warming, and we're starting to feel the costs across human and economic systems. 2020 was another record year. I won't go through the list here, but just to remind that we have today a new normal in terms of heat waves. 2020, we almost forget that now in the pandemic, that it started with the worst forest fires ever in Australia. You know that we now have the second consecutive severe drought and forest fire season in California, right as we speak. In Siberia, we recorded a complete shock actually to scientists, a 38 degrees Celsius temperature up on the Siberian Arctic tundra, which is, of course, contributing to speed up the permafrost thawing across the vast stocks of carbon in the peatlands in Siberia. and we have continued extreme events across the world. We also have new science emerging on the impacts at 1.2 degrees Celsius warming. You may have read this extraordinary paper joining forces of glaciologists across the entire world, showing that all glaciers, shown here with the red drops, the longer they are, the more mass the glaciers are losing, that all glaciers on Earth are losing mass. Look at the rapid pace of loss in Alaska. Look at the Arctic, the ground zero in terms of ice melt. On Greenland, the Arctic sea ice, but look also at the third pole, the Himalayas, which has been a discussed issue scientifically for many years. Now the evidence is unequivocally in place. The Himalayas are losing mass. They're not losing as fast as some other glaciers, but it's going downhill. And this is, of course, a geopolitical massive challenge because it is the water tap for social stability across Pakistan, India, Southeast Asia, and parts of China. But I will be focusing on this little blue marble and the state of science on the stability of the Earth system. This is the famous Apollo 8 picture of Earthrise, and we're now at this Earthrise moment because science now shows unequivocally that we are now at the transformative moment. This is the start of the decade when we need to cut global emissions by half. We need to halt nature loss. And we also need to understand even deeper the following question. Are we at risk of destabilizing the entire Earth system? We've come to that point. That is the point we now need to research. Here is perhaps the most important, I would argue, global climate modeling result of the last year. It is the first time a mathematical, physical climate model is able to reproduce the orbital forcing and the journey of our planet over the last 3 million years. So on the x-axis here, you have the entire so-called quaternary period, 3 million years. On the y-axis is the average mean temperature on Earth. The 0 point is the pre-industrial temperature, the 14 degrees Celsius world before we started burning fossil fuels. In green, you see the model reproduction of how the planet oscillates up and down from cold ice age periods to warm periods. And of course, there's really significant natural variabilities across the entire period. But at no point does the planet exceed or go through a 2 degrees Celsius threshold. The planet has been staying within a very narrow corridor, despite all the natural forcings, despite the massive journeys between deep ice ages with 70-meter lower sea levels on Earth, all the way to the warmest points. But it's always been within a maximum of 2 degrees Celsius warming, the warmest points, and a minus 4 to 5 degrees Celsius, the coldest point. And one important finding here is that one explanation why the planet has remained in this corridor is the planet's feedbacks and resilience. And we have the evidence for this. We have the seminal work in the Global Carbon Project, which is the global annual monitoring of all carbon emissions on Earth. Now, this is just the contemporary curve, but it shows the proof of Earth resilience. This is from 1850 until today on the x-axis, and you have on the y-axis carbon dioxide flux in billion tons of carbon per year. Above the zero line, you have the known to all of us, the hockey stick of burning fossil fuels in gray and deforestation in orange, the loading of greenhouse gases into the atmosphere. But as we know, it's not all of this that has caused the 1.2 degrees Celsius warming so far. No, we have this remarkable capacity in dark green of the oceans to take up carbon dioxide, up to 30%, and another 25-30% on land in light green. So it's only the blue part, which is the residual, that has warmed up the planet so far. And if you look at the graph, you see this super pedagogic story of a healthy planet. The more we stress her, the more the biogeophysical processes dampen and absorb and cool the planet. This is a healthy planet operating its biogeophysical systems to stay within the narrow corridor. You lose resilience and you risk crossing tipping points, and feedbacks may take the planet in the wrong direction. So this is the drama, and this is also something humbling, I would argue. We know with high degree of scientific certainty today that the planet has stayed within a very narrow corridor and that all the components of the Earth system supports its ability to remain stable. Unfortunately, we have more and more signs like this, showing on the left-hand side the seminal piece that came out just 3 weeks ago, that the Brazilian Amazon over the last 10 years has tipped over from being a sink of carbon to now being a net source of carbon. And there's so many papers supporting this finding of a gradual loss of resilience in the big tropical rainforest. And I just want to kind of make the take home point here that there's so much at stake because we are in the Anthropocene putting all this pressure, but look at the planet we're leaving. This is the ice core data just over the last 20,000 years, just to really lift out the details. Again, on the y-axis, you have mean temperature on Earth. So the 0 point is the pre-industrial 14 degrees Celsius world. We leave the last ice age 20,000 years ago, start the journey out of the ice age from the deep, deep -4 degrees Celsius world. And look at what happens. We enter this remarkably stable blue line, the Holocene, a warm interglacial state of the planet. It is a ±1 degree Celsius planet. It has variability within it, but this is the planet we know. This is the planet that has enabled everything we value to be developed. The modern world establishes itself in the Holocene. Before the Holocene, we were just a few million people. We were hunters and gatherers. We were living in caves. We go into the Holocene, we invent agriculture, and off we go in this civilizational journey as we know it. And look at the journey we started taking when we stepped into the Industrial Revolution. The spiking vertical line that is now taking us currently on a 2.5 to 2.9 degrees Celsius warmer world just in the next 80 years. So that is what is at stake. And the latest assessment shows that, the Anthropocene is a pressure point. That in itself raises concern. But as long as the Earth system is resilient, we have a chance to stabilize. But the latest assessment shows that 9 out of the 15 tipping element system, the global commons systems that regulates the ability of the planet to absorb carbon dioxide, to cool the planet, is starting to show signs of instability, being on the move. We don't know in what direction. We're not suggesting they've crossed tipping points, but they are moving in the wrong, in a way, away from the stable range that we have seen over the past Holocene. Here are the 9, and the big finding here, which is at the frontier of science, admittedly, it's not as if we have conclusive findings here, are the arrows, that we have more and more indications that these tipping elements, not only are they showing signs of being on the move, but they are interconnected. So just to give you one example here, that when we have accelerated ice loss on Greenland and the Arctic summer sea ice, which releases cold fresh water into the North Atlantic, it has slowed down the AMOC, the Atlantic overturning of heat, and that this slowdown is affecting the Amazon monsoon, which can explain the rising frequency of droughts and forest fires over the Amazon, but it also locks in more warm surface water in the Southern Ocean, which in turn can explain the accelerated melting and the observations of big ice sheets sliding down into the Southern Ocean from West Antarctica, the so-called Doomsday Glacier, the Thwaites Glacier. So what you see here is this delicacy of staying away from tipping elements moving too close to thresholds, also because they are interconnected. So there's no surprise that science 10 years ago developed the planetary boundary framework. It was building on all this evidence that if we are in the Anthropocene, if there are nonlinear dynamics, if there are tipping points, of course we need to scientifically define quantitative targets that can give us a guardrail, a fence, a safe space, what I call boundaries of a safe operating space shown in green, by defining the systems that regulates the state of the planet. The 9 boundaries are, as far as we know today, from Earth system science, the systems we need to be managing for regulating the planet's state in that corridor. And it's not only climate, as you see, it's also biodiversity. It is forest and land system change. It's the global hydrological cycle. It is nitrogen and phosphorus that we're overloading today across the entire planet. It is ocean acidification. It's the stratospheric ozone layer and the 2 still unquantified boundaries on air pollutants and chemicals. As you may have seen, we have 4 of the 9 boundaries outside of the green safe space, which can explain also that we're seeing so many impacts, and the task now is to turn back as quickly as possible. We can come back to this if we want to discuss more in detail. I just want to flag to you that there are operationalizations of the planetary boundary framework across the world with studies and applications, for example, most recently for the New Zealand economy. We have also a connection between this earth sciences with the stability of economies, which comes closer to the financial sector. This is a study that came out quite recently showing the drama if we do not return into a safe space for climate. On the background here, you have the color of stability of economies, kind of the basic maps that you're so familiar with in terms of economic stability. The darker the color, blue-green, are the stable economies, the red are the more fragile economies. The black spots here are the regions that today have an annual mean temperature exceeding 29 degrees Celsius. That's a pure health threshold, meaning that above 29 degrees Celsius of average temperature per year, we have state of risk with regards to intolerable levels of heat for human health, potential mortality rates increase, and potential unhealth. So it's not a surprise that these black dots are in the Sahara Desert with very few people. But look at the hatched lines. These are the regions that will have more than 29 degrees Celsius in 50 years' time, 50, if we continue burning fossil fuels as today. This is, you just look at the map, and at least I get, very, very deeply concerned. I mean, here we're talking Brazil, the whole of the Sahel, the Horn of Africa, the Middle East, India, and Southeast Asia. 3.5 billion people, many, many vulnerable and fragile economies that would be living under conditions that do not support human livelihoods. This is, of course, a recipe for instability. And if you overlay that with the finance and the economy, I mean, you've certainly seen these studies that are now being published increasingly, showing on the upper graph here in dark red, the countries that under business as usual, just because of labor productivity decline because of higher temperatures, would be losing over 25% of their GDPs over the next 50 years, and 80 years, sorry, up until 2100. But you just have to look at how these maps overlap, that you have this kind of perfect storms gathering with health risks, economic risks, and inherent fragility coinciding. And we don't want that to happen. And we know also that this can spill over across the entire world, because it also shows in dark red here the assessment that these are the hotspots for migration, displacement, migration, conflict, which of course spills over in different regions of the world. So this is why we need that transition rapidly. And this is the IPCC summary showing that 2020 is the last point to bend the global curve of emissions if we are to stand a chance of landing in the safe space on 1.5 degrees Celsius climate boundary. The green pathway is the net zero world economy by 2050. It is taken into consideration that we only have some 400 billion tons of carbon dioxide remaining in the carbon budget. That green line translates to what we call the carbon law, which is inspired by the Moore's law of the pace we now need to innovate and transform. It says simply that if we cut emissions by half every decade, we follow that green line. And that green line is summarized in this graph. It's the gray curve, which is then bending the curve 2020, cut emissions by half every decade, and we have this net zero point by 2050. But as you know, this will not be enough. We also need to have a food system transition from the dark brown wedge here, food system being the single largest emitter of greenhouse gases, to become a sink, a part of the solution in the orange wedge from 2050 onwards. I mean, this is an agricultural revolution across the world. And then, as if that was not enough, we also need to start scaling carbon capture and storage at a scale that we haven't seen at all so far in the yellow line. And as if that was not enough, we also need to maintain nature's capacity to stay in the corridor, meaning the carbon sinks on land in green and healthy oceans in blue. And if we do all of this, we have this 66% chance of staying well below 2, a 50% chance of reaching 1.5. So that is what is at stake. And the carbon law can be quantified, and we do that increasingly, and can be connected also to different businesses. We know that we have a massive gap in emissions, as you certainly know from the UNEP Gap report. So we are not following the right track. There's so much at stake here with COP26 coming up later this year. So the financial sector is so fundamental. Science is trying to help this as much as possible, not least through this initiative, the Global Commons Alliance, where we now have set up an Earth Commission to the left, which is an attempt to collectively across disciplines define a safe and just space for humanity on Earth, and then translate that to science-based targets, just like we do for climate, the Science-Based Target Initiative, but to have also for the other planetary boundaries, the Science-Based Target Network. We also see momentum of quantified targets that can guide investments in the financial sector. We have the 1.5 degrees Celsius target for climate. We are now seeing emerging a global goal for nature, which will hopefully land on the table for the Kunming UN Biodiversity Summit later this year in October. And what this is saying today, which is a proposal, is to halt the loss of nature from 2020 as a reference point, equivalent to the net zero loss of emissions, and be net positive by 2030, which would mean reaching an inflection point on nature loss over this decade and reach back to surface through regeneration and investments in all forms of nature-based solutions, and then move towards full recovery by 2050. So I'm just sharing this as an attempt to show that we're starting to see a portfolio of guardrails for climate and nature in the policy sphere, which I think can be very valuable for the banking sector to be guided by. 1.5, cutting emissions by half for climate, zero loss of nature, and nature positive by 2030, giving a very good alignment for investments in nature-based solutions. Is there reason for hope here? I would certainly say yes. I think what happened after the Biden summit with the establishment of what I call, at least, it's not there formally now that we have a G7 in just around the corner, that we now have a G3 on climate. We have the three largest economies, the US, the European Union, and China, stepping up behind science to define science-based targets for climate. Net zero loss by 2050 for the US and the European Union, no later than 2060 for China. Not fully aligned with science, but this will spill over across the economies in the world, because here are the three big ones stepping up and saying that in 30 years' time, we will be off fossil fuels. And of course, at the Biden summit, which you know so well, and I'm so impressive and really admire the leadership provided by the private banking sector of establishing the Net Zero Banking Alliance. I mean, you are sitting at the tap determining the investments in infrastructure. So you determine the long-term chances we have over the next coming decades. And I think this initiative is extraordinarily important, so strongly supported by the Partha Gupta UK government initiated commission on the economics of nature, which also provided additional evidence that now we need to have a turnaround, internalizing all the externalities, running the taxonomy, as President Parmelin pointed out, for the economy, and recognizing, which is this is taken from one of the leading economists, that the economy must now operate within the planetary boundaries. It has to be guided within scientifically defined, non-negotiable guardrails for a stable and resilient Earth system. So things are happening. And of course, with Mark Carney sitting at the helm for the finance run-up for COP26, with all the momentum that you are part of scoring on, I think there is a real window here. Of course, we have to get the 1 trillion from the European Green Deal to really start working for a zero carbon, nature positive future. You're sitting right at the center there with the financing of the transition. I'm quite concerned here that the 1 trillion seems to be kind of allowed to be used in so many different ways. But we are, at least at the Potsdam Institute, engaging, for example, with the network on greening the financial sector to connect the scientific necessity with the kind of directions for the financial flows. And I'm really excited about that. And I think you're sitting like almost at the center stage of what I think all are hoping for, to be a social tipping point. So this is my last slide, just to say that I think we all recognize that it's a very turbulent time right now. We're in this post-COVID transition. We have so many elements of change, of mass movements, political progress, the market forces. The market forces are fundamental. that is starting to become so obvious that zero carbon electric mobility, for example, outperforms economically, even without subsidies, fossil fuel based mobility. So we have these disruptions occurring, but we're not yet fully across the threshold. And the question is, how can we speed up and scale this process? And I think the private banking sector, you are one of the key elements for success in this journey. So with that, thank you so much, and back to you.
Thank you very much, Johan Rockström, for this very clear, powerful, striking presentation. We have received a couple of questions. I would first like to ask you that the first question is, do you think that the IEA latest net zero pathway is realistic?
Yeah, thanks for this question. And I should start by saying that we, myself and our colleagues at PIC, have not gone through in detail the very, very rich IEA report. But overall, we are assessing that this is a very important step forward. It is IEA really recognizing that we now need a transition to a 1.5 degrees Celsius future, and they are actually putting quite realistic ranges on negative emissions in particular. They are putting realistic ranges also on the food system transition. They're not exaggerating any of the nature-based solutions or transitions of non-CO2 gases. So all of this leads to a conclusion that IEA has done a scientifically robust assessment, which leads to a net zero landing by 2050. So the question then is it realistic? Well, I think their assessment is, which I support, that this is possible to achieve. The question is, will the political and economic system really step up to deliver at that scale and pace? So it's still to be seen, but I think it's, if you look back at the IEA reports of the past, this is quite a significant step forward.
Another question about control. Who should control actually the application of the ESG criteria? This is a very interesting question. You were talking about a G3. Do you have an answer?
Well, of course, we have for the different domains we're talking about here, we have weak, but we do have international regulatory regimes. So I think they should continue being strengthened and given trust to continue being the monitoring basis we have. So for example, for climate, that we have the UNFCCC, we have the entire Paris, legally binding Paris Agreement. And I think that those mechanisms should be used also for monitoring and keeping the verification, the MVR parts functioning. Then, of course, how it plays out for different sectors and different geographies, I think it will vary. I mean, just look at the European Union, where we now have the emergence of two ETS systems. I mean, one in the traded emission trading system, but also all the non-traded sectors like transport, for example. And of course, this will be a question of national, let's say, monitoring systems combined with regional. So I think it's not easy to answer that question in terms of I don't foresee there will be some kind of one global point for all checks on ESGs, but I think there will be multiple points of control.
Okay, I have one more, not easy question, actually, pretty tough one. Which organism should control the quality of financial products who are said to be green, and how can we avoid greenwashing?
No,
Let's try to make it short. I know it's a big question. Greenwashing is a big question, but maybe on the which organism should control, do you have an answer?
No, I don't have a direct answer because that organism does not, unfortunately, does not exist, formally speaking. I think we need to seriously put in place more kind of scientific committees that help in the quality control of different ESG measures, and same goes with all forms of offsetting, for example. Now there is a very messy market out there. Of course, we have some of the UN initiatives like a global compact and others, and I think they should be also strengthened in many cases, depending on sector. So again, it's quite a diverse landscape out there, but it needs very significant support for strengthening.
I would like to ask the audience here in Geneva, or do you have question? We have a microphone here, and I would like to let you raise your hand if you're interested in asking a question to Professor Rockström. Okay, great. So if it's not the case, I would like to thank you, Professor Rockström, for this very interesting, powerful presentation. Thank you for being with us this morning, and have a nice day in Germany.
Thank you so much. Good luck with the next continuation of the congress. Thanks.